welcome back. Let's hope you grabbed a glass of water and some paper to try the questions yourself if you haven't thought of asking these yet. You see something you'd like to see if you could do, that'll be great. Please remember to contact us on 0861 058 262 or on www.facebook.com/learn extra with an X. And good news is we've had lots of people sending stuff through to our Facebook page. So I'm going to try to address some of the questions that are coming through on Facebook. Let's start first of all with this one from Annika Johnson. It's a lovely little question. That was the one I was talking about before the break. You can see here it starts off and it says cos of 105, cos of 15, over cos of 60 minus x cos x, sine of 60 minus x sine x. Now immediately this bottom is screaming at me to say, hang on, this looks just like one of our formulas. Cos alpha, cos beta, minus sine alpha, sine beta. And you see, if I'm looking in a formula sheet, it's going to take me that much longer to find that. Whereas here, if I look at it and I know my formula, I can immediately identify it. So I can see that that would become cos of alpha plus beta. And of course, you can look that up on your formula sheet. This one here looks like it could be difficult, but that is an angle bigger than 90 degrees. So let's reduce it first of all and see what we get. And after the reduction, we make a decision on which way to go. Now, if I look over here and I want to reduce it 105 degrees, over here I've got 15, and I could write this as 90 plus 15 degrees. So that would make sure that this cos also works with a 15 degrees, and in fact it won't stay cos, because remember what we said to you about working with 90 plus. We've got to look at the ratio in that quadrant. So cos in that second quadrant is actually negative. So when we do it, it'll become negative sine 15 degrees. So let's go here and have a look. So as I said to you, because we're here 90 plus, we are going to look at sine being positive only, and this is a cos, so it becomes negative cos 15. All right, now I'm sure I can hear a few of you saying, oh, that's not good because not cos 15, I nearly made a mistake there. Just as well, I am a little bit awake this afternoon. It's sine. Remember, our ratio changes from cos to sine. And I'm sure you've had your teacher show you this. Cosine becomes sine, or sine becomes cosine. The co comes from the word complement. And complement, if you remember your basic geometry, means adds up to 90 degrees. Okay, so that's really where that comes from. So that's why the co is coming in there. All right, now that's good news, because already we're starting to think, that's good. That also looks like a formula I've seen before. Okay, but let's leave it for now. Let's go to the bottom of this thing and let's work with what I saw here. I know this can become the cos of the first angle, which is 60 degrees minus x, added to the second angle, which is just x. Now that's very good news, because over here I'm still going to leave the top exactly as it is, Annika. So it's not going to change at all. And look at me here, I'm leaving off my degree signs. I'll just talk about that in a moment, because you obviously have to be aware of what happens if you do things like that. And that's going to be the cos of 60. Now before we go on, I just want to mention that if you do leave your degree signs off, it depends on the marking team. What normally happens in a matric marking center, they will decide that question 5 required you to write your degree signs. And so on question 5, they will penalize you if you leave them off. But the good news is usually they don't penalize you on every question you do it on, but rather make a habit of putting them there than not putting them there. But just know that if it is something that you're inclined to do, the chances are you will only lose 1 mark over the whole paper for that error. But try not to lose the mark on something that you can remember to do, especially at this stage of the game, especially with tomorrow looming. And I'm sure tomorrow there's going to be lots of excitement when you finished your paper too, and you're all smiling and happy. Right, so let's have a look at what happens next. Now, remember, this is now a special angle. Notice I'm still not trying to engage with this, because although I recognize a formula here, I recognize the formula sine 2 alpha is 2 sine alpha cos alpha. And if you look here, I've only got this part. I haven't got that, and I've got a negative, so let's first see what we're going to get. Right, so now the cos of 60, depending which method you're using. I think probably most of you are using the triangles, I think. This is 30 degrees, and this is 60 degrees. If I want cos, it would be the adjacent side over the hypotenuse, so it'll be a half. Now that has just solved my problem for me, but I'm going to show you what happens if you ever get into a position where the problem is not easily solved like this one was. Okay, so what I do now is I say that's minus sine 15 degrees cos 15 degrees. And I know that if, oops, I nearly went to the wrong pens. If I'm dividing by a fraction, I can times by its reciprocal, which is what I do. And this now becomes minus 2 sine 15 degrees cos 15 degrees, which is very good news because now I'm looking more like this. I've just got a negative, which is not the end of the world. I can ignore the negative for now, just leave it outside, and say this guy becomes sine of 2 times 15 degrees. Of course, you don't have to show that step. You can go straight to negative sine 30 degrees. But if you do the step, it's also fine. Now, once you hear the sine of 30 is a half. And that's the end of this question. So, Annika, lovely question. Nice bits and pieces in it. It's got you to use some reduction formula, got you to use some compound angle formula, and it got you to use special angles. So that's the beauty of trigonometry. The fact that in a question you can have 3 or 4 subsections in the same question. So lovely question. Thank you, Annika. Let's try to the next lot where we got some more off Facebook. And this one is a very interesting question. It says if sine 36 degrees cos 12 degrees is P and cos 36 sine 12 degrees is Q, find in terms of P and Q the value of sine 48 degrees. Now what I do is I always look at this and I say to myself, okay, fine, if that is the case, and I think we better use the pink, I think, on this, 36 and 12 are the important angles. Can I see that in my 48? And yes, I certainly can. I know that is equal to the sine of 36 plus 12 degrees. It would be the same thing as saying sine 48. Right, so if I'm going to do 10.1.1, I can use my expansion on that. Now, what I like to do with these expansions is I always start by saying that if it's a sine, it will go sine, cos, sine, cos. Of course, you can look on your formula sheets as well. This would be 36, and this would be 12, and then this would be 12, and this would be 36. And sine always has the same sign, so it's a plus. Now, of course, you can have looked on your formula sheets and got that in no time. Now, if I look up here, sine 36 cos 12 degrees can be replaced with a P. And sine 12 cos 36, it doesn't matter if the order here is the other way around, can be replaced with a Q. And so there's our answer for the first one. Okay, good. Now, the next one talks about the sine of 24. So remember I said to you the key angles are 36 and 12. So how are we going to make a 24 become a 36 and a 12? All right, I can hear you all immediately shouting out the answer. I'm sure you're sitting at home saying, you know, wow, I know how to do that. Well, obviously, one way to do it is to say that is the sine of 36 degrees minus 12. And once again, using the expansion, it's sine, cos, 36, 12, 36, and the sign is the same, it's a negative. And of course we know that that one is equivalent to P, and this one is equivalent to Q. All right, so relatively easy to get that, no problem there. I think the problem comes with the next one, which we'll spend some time on. Right, so before we move off that, just to recap, my key is that I wanted to try and use these two angles to get that, and so nothing much can change here. We still got a 12 and a 36 that could work, but I can already see we're going to hit a little complication, but we will work with it and see what happens. So 10.1.3, I just need to get the question. It's the cos of 24. And if we decide to go this route, now I'm just looking over here and thinking, is there a cleverer move? And I don't think so. I think we are going to have to go that route. If we need to, we'll go and regroup. Now, what's important here is I think you realize that I'm seeing this question for the first time like you are. Some of you have seen it. And I'm not panicking about it. I'm saying, okay, so far the two questions have worked very well just using the basics. And hopefully this one will have a way to sort itself out. So let's see what happens. So this becomes the cos of 36 degrees minus 12. Just like we did with the other one. But of course, this time we're not going to have it as easy as the last time. We're going to now get cos, sine, and we're going to have 36, 12, and with cos, we have a different sign, so it's a plus, 36 and 12. All right, now we can see that this is not as easy as the previous ones in that we could just go and recap and replace them. So what we're going to do is we're going to go over here and we're going to see what we can do. Okay, we've got the sign of 24. I'm just trying to think if there's a better way. I don't think so. Let's just play on with this. So what I know that sine 36 cos 12 is equal to P, and sine 12 cos 36 is equal to Q. I just want to keep it handy so that it's easy to refer to. So if I look over here, I could say, right, let's bring it so that there's only sines and coses in here. So let's start by saying, okay, cos 36 can be replaced with Q over sine 12 degrees. How did I do that? I said I want to get this on its own, so I divide both sides by that. And cos 12 degrees can be replaced with P over sine 36 plus sine 36 sine 12 degrees. Right, I don't know if this has helped much. This is quite a hideous question, actually. It's quite difficult. There might have been a better way. We'll think about it as we go. All right, so we've got this looking at us. And immediately I'm thinking to myself, let's take a common denominator. I don't know if that is the only way to go, but let's see. We know that sine 36 can be replaced very easily with what we worked it out to be. No, we didn't work it out. We worked out sine 24. Okay, this is interesting. And 48. So I'm just thinking, 48 and 24 is a double angle. You know what? I think there's a better way to do it. So let's just stop here for 2 seconds and let's experiment. If it doesn't work, we'll go back to the way we were doing it. I'm just looking at this and thinking, I'm sure we have a plan here that will work better. All right, first of all, I want to go over here and I want to start and just say that the sine of 48, if I remember rightly, was P plus Q. And this one was P minus Q. So if I look at the sine of 48 degrees, I think this is the much nicer way to do it, actually. It's amazing how you don't see something and then suddenly you see it. It's sine 2 times 24 degrees. Okay, so the sine of 48 degrees, oh yes, this is infinitely easier than the route I was taking. This is going to become 2 sine 24 cos 24. All right, now you can see the sine of 48 was P plus Q, and the sine of 24 was P minus Q. And here's my cos 24. So the only unknown in this expression is the cos 24. So then all I would have to do to finish this question, and this is infinitely easier, but sure, quite difficult for you to see, I would guess that this probably had an A part to it, because I think for them to drop you, mind you, it says 10.1, so maybe not. Okay, so what you would do now is you divide both sides, oops, wrong pen, divide both sides by 2 P minus Q on this side and 2 P minus Q on that side. So the cos of 24 degrees is equal to P plus Q over 2 P minus Q. Okay, infinitely easier than the route I was about to take. I was going to take quite a while to solve that question. Just to tell you why I suddenly thought, hang on, 24 is half of 48. Why would they have asked me to work those two? Well, there's a link. The 48 is a double angle, so I can then use it effectively to sort it out. Very clever question, but I must be honest, quite mean. I think if I'd given this to my students, I would have had this would have been 10.2. And my 10.1 would have been something that reminded them about the sine 2 alpha equaling 2 sine alpha cos alpha. Something just to remind them, just so they made the link in some way. But you know what? It's fine. If they didn't warn you on it, it's not the end of the world. We can always cope with it. And as you can see, if I carried on the other way, I probably would have taken a lot longer to solve the question. But what suddenly stopped me was I thought 24 and 48 are half of each other. Why did they ask me to work that out? So just think about that. Okay. Great. Okay, so that's that question. Very nice question. I don't know who sent that in, but it's a very nice question, so thank you for that. Raised some interesting issues. Right, the next one that was sent in is another one that also causes great fun in games, and I've seen this one many times before. It says, show that this happens. Now, they're kind. They say hint. hint, 40 degrees is 60 minus 20 and 80 degrees is 60 plus 20. So they've actually helped you out. So if they don't do that, that was quite a mean question, but with that it becomes very easy. So on the left-hand side, we would leave the sine squared 20 degrees alone. We would go to the sine 40 and change it to 60 minus 20. Of course, we're in for lots of fun. I'm sure you can see that. And over here, we're going to change the 80 to 60 degrees plus 20. But a little hint, if you ever get something where it's like 15, 30, 45, or anything where they're like duplicates or triples or quadruples of a number, it's often best to try and find some link in some way where you can add a special angle and another angle and get that. And so usually this is your hint. So the 20 is the only one that's quite small. And so you say to yourself, what can I subtract or add with a 20 to get a 40, and what can I add or subtract with a 20 to get an 80? And the moment you do that, you would get this hint, which they so kindly provided for us. So we are happy that they did that for us. So right, this is equal to sine squared 20 degrees. Now over here, the expansion only works for this. This square, in effect, is going to go outside the expansion. So this is going to become, oh, I forgot my plus sign. That would have been quite tragic. It would become sine 60 cos 20. Remember, sine keeps the same sign. Sine 20 cos 60. And likewise, this square again is going to go outside it. So we're going to say this is now plus, and again we're going to say sine 60 cos 20 plus sine 20 cos 60. Sure, quite a squashed drawing. I'll try and be a little bit less squashed. Let's extend the page and write more over this side so we've got more room. So we still got our sine squared 20. Notice I haven't really worried about what the other side's telling me. I'm just thinking, let's get it all to 20s and then we can work with it effectively. Right, so what we're going to do is we're going to look at this and we're going to say to ourselves sine of 60, and you can use whatever method you want, is root 3 over 2 cos 20 minus, and cos of 60 is a half, sine 20. Okay. And that we've got a square, and over here we're going to do the same thing. We're going to say it's root 3 over 2 cos 20 plus a half sine 20, and it's all squared. So we've got sine squared 20. Now you know why your teacher in grade 6 and, oh not 6 and 7, grade 8 and 9 drilled you so much on multiplying out brackets, because here's the time when you have to actually use it. So let's show you. This is going to become, if we square this bracket, we square the first term, which will be 3 over 4 cos squared 20. We multiply these two together, so that's root 3 over 4, and we double it, so it's going to become minus root 3 over 2 cos 20 sine 20. And we square the last, which is going to be a quarter sine squared 20. Now the same is going to happen with this thing, and just to make it easier to see what I'm doing, I'm going to do this one in orange. So we square the first one, it's going to be 3 over 4 cos squared 20 plus, and again we times those together, so it's root 3 over 4 doubled, which is root 3 over 2 cos 20 sine 20. And then we're going to have plus a quarter sine squared 20. All right, things are looking better. So let's go back to the green pen so we don't get confused. It's sine squared 20 degrees first of all. And then I see that, hang on a moment, over here, this one and this one will counteract each other. And over here I've got like terms, so 3/4, whoops, press the wrong button. 3/4 plus 3/4 is going to be 6/4, which is 3 over 2 cos squared 20. And over here, if I add that and that, I'm going to get a half sine squared 20. Now, if the fractions are getting you, don't worry, you have got a fraction button on your calculator, and you can always do that kind of adding on your calculator if it's a difficult thing for you. Now, if I add those guys, I've also got 1.5, or 3 over 2 sine squared 20 plus 3 over 2 cos squared 20. And of course, the very good news is I can take out the 3 over 2 as a common factor, giving myself sine squared 20 plus cos squared 20. Right, which then becomes 3 over 2, and of course you recognize that as one of your square identities, which is just 1. And so your answer is 3 over 2. Lovely, lovely, lovely question. So I must say, thanks to our Facebook people who've been sending in this wonderful stuff. I'm not sure how much time we've got, but I think it's time for ad break now. So I'm sure we've got some more still waiting, so don't be gone for too long. Grab some water, just be ready to go on the next part. Hopefully there's some other nice challenging questions after the break. Remember to get us on 0861 058 262 or on www.facebook.com/learn extra. And it's nice to put your name in so I can say thank you for the questions. So remember to do that.